So continuing with question 6, which is the searching question. Here is the pseudocode for a different algorithm to find all of the occurrences of mileage over 300. Okay, so important that you know what you're looking for, otherwise you're not going to understand what's going on. Set count to 0, 4. So this time we've got a for loop. For each entry from mileage, do, if entry is greater than 300, then set count to count plus 1. So there's our test. We're counting if it's over 300, and then we're counting it. End if. End for each. For each is just the same as for. It's for every item in the list, isn't it? So for I in, for every item in the list, do this. And then send the thing to say. Small data set, remember it's a small data set, but we're modeling what would happen with a large data set stored in the array called mileage, so for each entry, that makes sense. And this time it is sorted. Okay, so that's different from the previous question, but we've got to describe one inefficiency when executing the algorithm with this data set. So this time we are looking at it with this data set. Okay, it's a subtle difference, isn't it? And it is about looking hard at the questions and reading them carefully. Just nip back to this one. Okay, well, that talks about this data set as well, actually. So I'll come back down here. So with this data set, so what will happen with this data set? We're going to do every entry is going to go in. So 10, 20, 30, 40, 50, 60, then it will stop, and then count will equal to 0. So an inefficiency with this particular algorithm is that there's no need to search for it, search for it at all, because there are no mileages over 300, and if we could modify the program, we don't actually need to do the for loop. It would be a lot faster, so it would be a lot more efficient. So I would say that the answer in this data set, something like this, in this data set there are no values over 300, so the for loop is not required to run, and yet it will run until the end of the array, and count will never change. Something like that. So a linked answer, again, you need to have some sort of explanation. So my explanation is there's no values over 300, and so that's an explanation. Let's see what the mark scheme says. The loop means that all records will have to be looked at even though there are no numbers above 300 in the list. Okay, so the loop's going to run even though there are no numbers over 300 in the list. Okay, so that's that one. I think I'll continue on this with this final question, or final part of this question, which is a similar question. The search algorithm will be used with a very large data set. The efficiency of a linear search algorithm can be improved by pre-processing the data set. State interesting. State and explain. Explain how. Okay. A type of pre-processing and explain how the algorithm in 6i2, so the one with the for loop, could be changed to use the pre-processed data efficiently. Right. So having obviously you need to identify whether your efficiency there, and now your inefficiency rather, and we've got 3 marks for this. So let's think about this. Now, pre-processing means doing something to the data before you do the main task. So pre-processing, doing something. I know I don't like the word something, but in this case we're going to identify what the something is in a minute. Doing something to the data before, no, that's right, before I thought I'd hit another key before executing the main process. Okay, so our main process is a search. What can we do before the main search in order to improve our efficiency? Now, I think that there are clues coming from this part of the question, previous question, which was a random list. They then sorted the list. So sorting for sure is going to help make it more efficient. Think of the purpose of the algorithm. The purpose is to find all the values over 300. So if we sorted the data and then we changed the algorithm, because it talks about changing the algorithm, to then only count items over 300, then it would be more efficient. Okay, so in order to only search the items over 300, because that's what we're looking for and counting those, the data would need to be sorted, and preferably, well, it depends which way you do it. If you sort them high to low, you can start your search at the beginning of the list. If you sort them low to high, you'd have to start at the other end. So I think it would be easier to start at the bottom end. So let's sort the data. So sorting the data from high to low, which is known as descending, so in descending order, sort the data, really thought about how I'm writing this, sort the data from high to low in descending order, and change the algorithm so that it starts at the beginning. Okay, so it's starting at the beginning, so we're going high to low, we'll have all the ones above 300. Starts at the beginning of the array and loops and counts until it reaches less than 300, when the loop should stop. Okay, now I've got 3 marks. I'm going to try and put a bit more explanation in. This means that, which is always a good starting point if you've got something. Well, let's read our question again. The efficiency of a linear search algorithm can be improved by pre-processing the dataset. State a type of pre-processing and explain how. Sorting the dataset from high to low. So I might change my words. Sorting the data from high to low is a type of pre-processing, and this changes so it starts at the top. This means that the algorithm, now I'm going to use the words in the question, would be more efficient because, okay, explain because the data has been sorted. I'm going to put pre-processed in brackets to show I've read the question. This means that the algorithm will be more efficient because the data has been sorted, pre-processed, and not all the data will need to be looked at. Okay, so whereas in previous questions or in previous algorithms you'd had to look at every single value before stopping, in this suggestion is that we're going to stop as soon as we reach less than 300, so it will make it more efficient. I hope I've written enough for 3 marks. Okay, I've mentioned what I think my pre-processing is, which is the sorting. Explain means I should really use the word because somewhere, which I have, and how is where we've changed it, so that I've put the how in there, how we've changed the algorithm. Okay, so mark scheme, let's have a look. Sort the list, yes. Direction of search, yes, yes, yes. Okay, 1, 2, 3. So that's what you needed to say, that you need to sort it, say what order you would do and how you would change the algorithm, and show what it was. So that's what that was all about. I think properly practice is what's required, but I hope this is helping in some way. So that is the end, I think, of question 6.